In this video, I'm going to be showing you two examples of how to use the kinematic equations to solve some problems. So let's start with example 1. It says Steve is parked illegally in a red zone when he sees a police car approaching behind him. In a panic, he accelerates from rest for 3 seconds until he reaches a safe distance away and a velocity of 30 miles per hour, which we're also told is 13.4 meters per second. Determine A, his rate of acceleration, and B, the distance he travels in 3 seconds. Organizing your calculations using 3 columns for givens, unknowns, and solution. And so this is sometimes called 3-column problem solving. It's a really nice way of organizing your thinking and your information. So let's start with the first column, which is givens. This allows us to list the information that's given to us that we think is going to be useful and that can be represented by a variable in one of our big 3 kinematic equations. So there's some obvious ones. We've got a given here of 3 seconds. So this is a time. We've got a given over here of a velocity. And we can put these in our given column. So I'm going to say t is 3 seconds. I'm going to say v is 13.4 meters per second. But there is one hidden given. A number is not provided, but the information is quantifiable. And it's right here. It says that he accelerates from rest. That means that his initial velocity is 0, right? Accelerating from rest means that you were initially stopped. Well, if his initial velocity is 0, then what velocity is this? We can call that his final velocity. So I'm going to add a subscript f. And now I've got some really useful givens. Okay, my unknowns are the things that I'm being asked to solve for. So I'm specifically told that the problem is asking for 2 things, right? A, his rate of acceleration. So I'm going to say A equals question mark. This A is representing acceleration. And then B, the distance he travels in 3 seconds. That would be his final position. The distance he travels in 3 seconds, final position. All right, so here we go. I'm going to organize my solution into 2 parts. Part A, where I'm being asked to find the acceleration. What I want to essentially do is look at my unknown and group it with my givens and say, does this information seem to fit with one of my big 3 kinematic equations? And I'm going to say, yeah, it kind of feels similar to equation 2. All right, equation 2 is this: v final equals acceleration times time plus v initial. I know the final velocity is 13.4 meters per second. I don't know the acceleration, so I'm going to leave that as a variable. I know the time is 3 seconds. And I know that the initial velocity is 0. Okay, basically means it goes away. So in order to find the acceleration, I'm going to do some simple algebra. I'm going to divide both sides by 3 seconds to get rid of that and to isolate A, the acceleration. And so the acceleration is going to be 13.4 meters per second divided by 3 seconds. And that gives me 4.47. And then what are the units? Well, they're actually right here. Meters per second per second. That's part of dimensional analysis, right? Or 4.47 meters per second squared. So this is my answer for the first part. Let's try part B, where I'm being asked for the final position. So I'm going to go back to my columns and I'm going to say, gosh, if I'm looking for the final position and I have this information, Is there an equation that feels like it groups those variables together really well? And I'm going to say, yeah. Let's use equation number 1. Which was that the final position is equal to 1/2 AT squared plus the initial velocity times time plus the initial position. And so I can just plug in the numbers. I now know the acceleration from here, so I can actually stick that in right there. 4.47 meters per second squared. And then the time is 3 seconds. Don't forget to square it. The initial velocity is 0 times 3 seconds. Doesn't really matter. That's going to go away, right? And then plus the initial position. Well, he's starting from rest at a certain spot. So I can say that his initial position is just 0 because I wasn't really given any other information about him starting at some other position. So I can just call it 0. And then if I go ahead and multiply this out, in my calculator, I would do 1/2 times 4.47 times 3 squared. I'm going to get 20.1. And then the units are a little bit tricky. Let's see if we can follow this. So I'm going to have 3 squared here, and I've got 3 squared on the denominator of this. So those will cancel, and I will be left with meters uncanceled. So those are my units for my answer. And that makes sense, right? Because it was asking for a final position, 20.1 meters. That's how far Steve is going to get after 3 seconds.